Hi everyone. So in this video tutorial we're going to solve an integration problem. Say we have a definite integral that is going to be solved by changing of variables. Okay, so in this case we're going to be changing everything that has x in terms of u. Okay, so we're going to choose u as our special letter that we're going to use in this problem. So we have to understand that there are differences, minor differences between u substitution and change of variables, in the sense that we have to also upgrade or change the limits as well. Okay, so the first step that we're going to consider is to let u to be everything that's in the brackets here. So we're going to say step 1, right? I'm going to say let u be equal to 2x plus 1, right? So the second step that we're going to do is to make x the subject of the formula, right? We're going to make x the subject. So here, that's where the difference is when you are doing it by u substitution and changing of variables. So that's how the difference is. So here we're going to say equal to u, x is now going to be u minus 1, and x, you understand, so when x squares on both sides, you're going to have this, right? So this x here has already been done, and this guy here has already been done. So what's the next thing that we're going to do? The next thing we're going to do is to differentiate this one. Okay, we're going to differentiate this one. So we're going to say we're also going to find du dx. Okay. Oh, sorry. We're going to find this one. So we find the derivative with respect to u now. Okay, with respect to u. So we're saying dx du, which is going to be this one. So you drop the power, okay, and subtract 1. Okay, so that you have the negative there. Okay, and you agree with me to say this one is as good as saying this by the laws of indices. Is as good as saying this, which is this. When you simplify, you're going to get this. Okay, so this is right. From here now, we're going to make dx the subject of the formula. Okay, because the entire sense is to have this one in terms of u. Okay, so you understand to say here d, we're just going to cross and multiply there, and dx is going to be du over 2 root of that. Right, so we're now going to replace this one, and this one in the original equation. Okay, so that we have this. Okay, so that we have this, the limits which as well have to be upgraded, okay, later, at a later stage. So we're going to have where there is x there, where there is x here, we're going to put this, okay, multiplied by u to the power of 3. Where there is dx there, we're going to put du. Okay, so we say dx is equal to du to like that, not so? So from here now, we can see what's common, so that we cancel them out. So this guy and this guy, right? So that we have this one, which is a constant now, and it can come outside. So we have this, right? The upper limit. So this as well. Then we have the u. Then here we just have okay. So this is what we're going to remain with. Here down we're just going to remain with a 1. So we're supposed to upgrade the limits when we're changing variables, unlike when we're doing u substitution. So what we're going to do here is we understand to say u is equal to x squared plus 1. So we're going to have the upper limit like this, okay, so this is going to be 2. Then the lower limit is going to be 0 squared plus 1, right, which is just going to be 1. So those are the limits that we're going to use. Okay, so finally we're going to have this, then 2 and 1 here, so that now we have this, right? So from here now we are ready to do the integration. We're ready to do the integration. So when you integrate that one, you're going to have, 4 you add, then like that, then you indicate your limits as well, so that this is going to give us this down there 8, then you have your limits like that. So this one now is going to be 2 power 4 over 8 minus 1 power 4, right, over 8. So these are the same. So I'm going to have this is 16, that's 15, that's 1, so I'm going to have 15 over 8, and this is going to be our final answer. Thank you for watching. Consider subscribing and also liking, sharing our videos. Thank you so much. Bye.